Megan, if my screen freezes, let me know because I've been having a few issues with my screen freezing on these Zooms in here. Not as bad as the 401 was, but still a little bit. All right, y'all. So this 6C is going to talk mainly about what we call the normal distribution. And I'll write about what that is. So the normal distribution is a symmetric L-shaped distribution with a single peak. Its peak corresponds to the mean, median, and mode. All right, so what did I say? The mean, median, and mode. Of the distribution. And in its variation, is characterized by standard deviation of the distribution. What's that? Of the distribution. Okay, well, then I got what we call conditions for a normal distribution. We really got 4 conditions we got to worry about on these. Most of your data values are clustered near the mean. So most of the data values are clustered near the mean. Given the distribution a well-defined single peak. Okay, so remember, the mean is the average. So most of these values are going to be centered up around that average that you're getting on these, okay? The data values are spread evenly around the mean, which makes the distribution symmetric. And then it was making the distribution symmetric. So what they mean by symmetric, it's gonna, if you was to cut it right in the middle, it would look the same on both sides of that, okay? Larger deviations from the mean are increasingly rare. So what they mean is the further you get from your average, those values are going to be less common, okay? So the larger deviations from the mean are increasingly rare. And that produces the tapering tails of the distribution. Remember, when you look at this distribution, you're looking at the frequency that these values occur. So if you're right around the mean, you're going to expect most of your values to be right around the mean or the average. But as you start deviating further and further from the mean, you'll notice it sort of tails down. So those values are not having a high frequency like the ones in the averages there, okay? And then finally, the individual data values result from a combination of many different factors. Individual data values result from a combination of many different factors. Okay, so I'm going to draw y'all a normal distribution. And this here is what we call the 68, 95, 99.7 rule for a normal distribution. All right, I'm going to draw this. All right, well, this is going to be the frequency on the y-axis. I'll draw that where that'll come down here. So frequency. Remember, frequency is how many times you get those values. So right in here in the center is going to be my mean. I'm gonna try to draw that. So this bell curve sort of comes down on both sides of that mean. So your mean is going to be right in the center here. Remember, that mean is your average on that, okay? So then, remember last week when I was looking at the standard deviations, and what we did, we took all the data values and subtracted the average, and then I squared that, added them all up, and took that square root. Those were finding what we call the standard deviations. So this would be plus 1 standard deviation and minus 1 standard deviation. So 1 standard deviation from your mean. Then we'll draw another one of these. That's going to be plus 2 standard deviations. And then over here, we'll have a negative 2 standard deviations. And then finally, at 3 standard deviations. So this will be plus 3 standard deviations. And over here will be minus 3 standard deviations. So this 68, 95, 99.7 rule is going to apply to this standard deviation. 68% of the data will be within 1 standard deviation of the mean. So this is 68%. So what that means is if I had 100 samples, 68 of them are going to be within 1 standard deviation of my average. So if my average was 50 and my standard deviations were 5, that means that I'll be between 45 and 55 with 68% of my data, okay? 2 standard deviations. %95 of my data will be within 2 standard deviations of my average. So remember while ago I said 50 if that was my mean, and my standard deviations were 5 and 5. Well, 2 standard deviations would be at 40 to 60. So between 40 and 60, 95% of my data points will be in that range, okay? And then finally, we had the 3 standard deviations. Well, guess what? For 3 standard deviations, 99.7% of my data will be within 3 standard deviations of my mean. So that leaves me less than 1% that we would really call extreme outliers because they would be a lot further from my averages, okay? So 68% of data will be within 1, 95 will be within 2, and then 99.7, which is pretty close to 100%, is going to be within 3 standard deviations of that average, okay? All right, so they'll ask you questions like that on the homework, and I'll sort of show y'all some of them and see what they're giving you with, okay?
So the dates, you might have already said this. We pushed the dates back.
Yeah.
I tried to do this.
Yeah.
Now it's making sense.
I was looking through it, and after this week, we'll be really close to getting back on schedule. We might be 1 section behind or so still. Because there's a lot of optional things that we're not going to worry about that they put on there for optional. So 6C is really the last one in 6, and then we'll get into like 7A and stuff like that. Okay. Now, y'all not had any problem getting into the homework, have you? Because I did have one student said that it was saying that it was expired or something, but nothing should be expired on y'all, because I keep them all in and let you go past on them due dates, so.
I haven't had any problem.
Unless it was something maybe from the beginning they were doing, I don't know. I tried to ask them what section and I didn't get a reply, so who knows, right? All right, so standard scores. And this goes back off these standard deviations. So standard scores, the number of standard deviations a data value lies above or below the mean is called its standard score or z-score. It is defined by, and that's sort of what that little sheet I was giving y'all. So I need one more back there. I sent an email with this, but since y'all are here, I'll give y'all a live copy. So Z, which is your standard score, equals the data value minus the mean or the average divided by your standard deviation. Now, we do know this. So like if my mean was right here, any data values that were above my mean would give me a positive z-score. Any values that are below the mean are going to give you some negative z-scores, okay? So above is positive z's and left of that mean is a negative z's, okay? So let me play up an example showing you what they're going to sort of do on these. So it says an IQ test is scaled so that scores are normally distributed with a mean of 100. So IQ test has a mean of 100. Standard deviation of 15. So we got a mean of 100, standard deviation of 15. We're going to find the standard scores, but I could also call them standard scores, z-scores. So you want to find the z-scores for IQ scores of 85, 100, and 125. So think about this. I've got me a bell curve sitting here. And they're telling me that my mean is 100, right? And then this would be my one standard deviation minus one standard deviation. And remember, the standard deviation is 15 on this one, right? So if it means 100 and the deviation is 15, that means that a score of 115 would be one standard deviation away. And then what about 100 minus 15? That would give me 85. So 85 would be minus one standard deviation. Then if I took that 115 and added another 15, that'd be 130, would be 2 standard deviations away. And then what's 85 minus 15? And that would be minus 2 standard deviations. And then I could keep going, right? 3 standard deviations would be what, 145 add 15. And then minus 15 from that would be what, 55 or so? Would be negative 3 standard deviations. So I just wanted to sort of see what was really going on. So anything that had a score between 100 and 115 would be between 0 and 1 standard deviation. Okay? Anything from 1 standard deviation to 2 would be a 1 point something type number, and so on. Okay? So we're going to use this formula with them 3 numbers. So let's start with 85. Z-score for 85 would be that data value, which is 85, minus my mean they gave me was 100. And you're going to divide that by standard deviation they gave me was 15. So what are we going to get? Negative 15 over 15, which would be what? A negative 1. Well, we knew that because there's 85 sitting at negative 1 standard deviation, right? So that's what that number is there telling me that, hey, that 85 score was close to my mean, but still it was at 1 standard deviation away from it, okay? Which means that scores between 85 and 115, what percent do we expect to get a score between 85 and 115? So what?
We expect 68% to be within that.
That'll tell me right there, right? 68% will be between 1 standard deviation of my data. Okay. All right, what's next? 100. So we know right here is sitting at my 85. So if I do 100, I got 100 minus 100 over 15. Well, that's what, a 0 over 15, which is 0. But guess what? 100 is my mean. So any score that's going to be 100, it ain't deviating from the mean because it is the mean, right? So it would have a z-score of a 0. And then I had a 125. Now notice 125 is going to be this way. So are we expecting positive or negative? Yeah, because that 125 is going to sit right around here somewhere. My z-score is going to be between a 1 and a 2. Y'all with me on that? So let's see what we get. So we're going to have z equals 125 minus 100 over 15. So whatever 25 divided by 15 is going to give us. So that should be at 1 point something something.
Yeah, you should.
Put that like 1.66666.
That's it.
So I might go what, 2 decimal places or so. But look at that chart I gave y'all. Oh, we won't use that on this one. We'll wait on this. Because it's giving you the percentile of people that'll get that score and stuff. So they're not really asking that yet, so we'll wait on that. But does this make sense? Any scores above your means are gonna be positive, any scores below are gonna be negative. And you're just really looking at how those deviations are going, okay? It's better than finding that standard deviation, right? Because finding the standard deviation, you have to subtract all that stuff, square it, add them all together, take the square root, remember, so. But what all that was doing was finding these averages. How far is these data points on average away from my mean on that thing, okay? So here it goes with the sheet. So percentiles. The percentile. Now y'all heard of this percentiles before, because y'all have ever done them high school tests they give you every year. I don't remember what they call them in Arkansas, but some states call it gateway exams and stuff like that. But y'all should get them like in junior high and in high school and so on, little bubble test.
Yeah.
They score everybody by percentiles, like, oh, you're in the 80th percentile for your group or something. All right, so the percentile of a data value is the percentage of all data values in a data set that are less than or equal to it. And what we say, if you got a data value that lies in between two percentiles, well, let's go with the lower percentile, okay? So a data value that lies between two percentiles is said to lie in the lower percentile. So basically, it's almost like a rounding down on these instead of up on them, okay? All right, so I'm gonna do an example and it'll sort of play with that little chart I gave you, okay? So some of these are actually probably trickier than what you're gonna do on your homework, okay? So this says cholesterol levels in men 18 to 24. So cholesterol in men 18 to 24. Is normally distributed with a mean of 178 and a standard deviation of 41. What they want to know for A, in what percentile is a 20-year-old man with a cholesterol level 190? So what percentile is a 20-year-old with cholesterol of, what did I say, 190? Then part B wants to know what cholesterol level, so what cholesterol level corresponds to the 90th percentile. And then they say that's the level at which treatment may be necessary. May be necessary. All right, well, two questions. First, they want to know what percentile is a score of 190, and then they want me to find what score of cholesterol level is going to give me my 90th percentile, okay? So I'm going to use that formula right here to get my z-score, okay? So I know my z-score is my data value, which is 190 that they gave me. Minus my mean, we said was,
178.
what was it?
178.
178. And then my standard deviation.
41.
Oh, it's right there, 41. So we're going to figure this out. It's going to give me a number, and then we're going to look on our chart to get that percentile, okay? All right, so that's what, 12 over 41, I think. We do a calculator out for that, right? If I got 12 and divided by 41, I'm getting like a 0.2926 or something like that. So I'm going to round that to maybe a 0.29. So we got a chart. And I'm looking at a score of a 0.29. Ooh, I'm way down on that. Let me see. So it looks like for 0.29, I'm in the second row of scores. Because what this is going way out. But 0 is in the second column, right by the 50, you see a 0. We were at 0.29. And mine goes from 0.279 to a 0.305. But remember, what did it say? If you were in between two percentiles, you're going to go with the lower percentile. So for a 0.29, I'm going to go with, y'all getting 61?
279.
So what it does is it does the zero there. And then where was you at? I'm at 0.29 right there. So what are you going to go, 61? Which means it's in the 61 percentile, okay? So, and like I said, you really couldn't get right on 0.29. So when you're in between, go with that lower score. And we said the percentile, what was that, 61 we said?
Yeah.
61 percentile. Okay? So that's sort of what this is doing. You can go from percentiles to z-scores or z-scores to the percentiles, okay? All right, so let's see on now. Now what was it asking me? It was asking me what cholesterol level goes to the 90th percentile. So what I want to look on here is find the 90th percentile somewhere on here. So for 90th percentile, so this would be B. Z-score is what? So find that 90th percentile, and y'all, that looks like what, a 1.282? So now we're going to work it in reverse because we're looking for what one of these cholesterol levels, okay? Now we know our mean was 178, so it's going to be way higher than that 178, okay? So now, let's find, I'll see what we want to do. What was my standard deviation? 41. So we take this number for the percentile and we multiply that by the standard deviations. So we're going to multiply 1.282 times the standard deviation, which was 41. Okay, so this is your Z-score times your standard deviations. So let's multiply that and get something. So was that 1.282 times 41? I'm getting around 52.562. Which I would probably round that off to an even 53 on this thing, okay? So this tells me how far out they went from my mean. My mean was 178. So now we take the mean and add it to our deviation. So that'd be, what'd you say, 178 plus 53. So add them together for me.
221.
221. So that tells me that if you're in the 90th percentile, your score is at least a 221, okay? So what they're saying is, if you're at that level, 221, you probably need to get some meds or something because your cholesterol's probably going to be fairly high, okay? And we know that was what, 1.3 basically on standard deviations. So it's in between 60-something percent, was it 68% and 95 or something like that?
Yeah.
We know they're in between them ranges on that, okay? All right, so that makes sense? So let me hit y'all with some questions real quick that they're going to ask y'all. I think I got them pulled up. So tell me if this makes sense. And that's what they sort of do on this homework is, does this make sense or does this not make sense? Does it make sense? Oh, let me share this for y'all online. So this question asks me, the heights of male basketball players at a local college are normally distributed with a mean of 6.3 inches. So they got a mean of 6.3 inches. With a standard deviation of 3 inches. So would that be possible? they're saying is your mean is sitting here at 6.3 inches. The standard deviation is 3 inches. So for each one of these, you'd be adding 3 inches, right? So that'd be 6.6, 6.0, y'all with me? I'm just taking off my standard deviation each way. Another deviation would put me at 6.9. And what's 5.9, I guess? 5.9.
Yeah.
Does that seem possible? Is it possible to have an average height of 6.3 inches with a 3-inch standard deviation? Because let's look at this. If I went out one more standard deviation, it put me at 5.6, right? And over here would put me at 7.2. But remember, 68% of that data is going to be between 6 and 6.6. 95 between 5.9 and 6.9. But those seem like good basketball heights, right? I can see where the average height would be 6.3, and the 3 inches would be the standard deviation, right? You're not getting no crazy values on that. You're not getting no people that are 8 or 9, 10 feet tall, right? Okay. So that would be possible. And let me show you one. That's probably not too possible, okay? So let me click. So those you're just going to click, make sense or don't make sense. So check this out. The weights of babies born at Belmont Hospital are normally distributed with a mean of 6.8 pounds. So the average weight of these babies is 6.8 pounds and a standard deviation of 7 pounds. So can your babies average 6.8 pounds and have a deviation of 7 pounds? No, because that means one standard deviation of 7, your baby's a negative 0.2 pounds or something, right? And if you go that way, you're getting a 13-pound baby. And then 2 standard deviations is saying your babies are between a negative something and a 20-pound baby. So something like that would probably not make too much sense, right? So that's sort of what they're going to hit y'all with on these homeworks. Does this make sense? And they just want you to realize that the standard deviations, you want to use them to see if that makes sense or not. What y'all ask? Let me ask y'all this. See if this makes sense or not. Jack is in the 50th percentile for height. So he is of medium height. So look on your chart, 50th percentile. What's your Z-score?
0.
Which means he is definitely in the median. Because remember, 0 is the mean, median, and mode on that normal distribution, okay? So if you're in the 50th percentile, you're definitely median height, okay? So that's just, they're not going to kill you. Let me show you this one, because there's three little charts we're going to look at. And this one's a little collar in there. And this one sort of takes off on this side, goes up. Two of them would be what we would call normal distributions. So let me see, this would be my A, B, and C. So which two of them would be more symmetric to you? A and B, right? Because look at C. C's got a little bit of a longer tail going to the right side. So they just want you to realize that your normal distributions are like mirrors of each side, okay? So this side would flip right on that side, but this one, if you was to cut it, it's not laying on itself, okay? Now, of the ones that are normally distributed, A and B, which one has the most variance? And that would be A. See, this one has a taller peak because it's got more values wanting to crowd in that middle to where, like you said on this one, you got more values that are going outward, so it's keeping the flatter peak instead of this real tall peak on it, okay? All right, the scores on the psychology exam were normally distributed with a mean of 64. So a mean of 64. Okay. Standard deviation of 6. All right, so let's see what they want to know on this. A failing grade on this exam was anything 2 or more standard deviations below the mean. What was the cutoff for the failing score? So y'all, if your mean is sitting here at 64, there's one standard deviation and then my 2 standard deviations. So this was 64. What was my standard deviation? 6. So you're going to subtract 6 from 64.
58.
And then we need to take 58 and go another standard deviation. So subtract from that one, 52. Which means 52 was the cutoff score for them failing or passing that, okay? So that's what they're wanting y'all is to realize that the standard deviations add or subtract from your mean to get to your values, okay? It's not too bad. Actually, some of them, that's sort of going off the charts that I was doing. Let's see, 8, same thing. Yeah. So some of them, you're going to look at the Z-scores like we did and figure out the scores, or you're going to get them Z-scores and convert them to percentages using this chart, okay? And we'll do them, sort of like I was doing that in A and B parts.
Yeah, I don't know. I think it's 231. Okay.
Oh, and this one?
Yeah, because the
231 right here?
Here's the one will be 31.
Okay, 231, there you go. So still high on that cholesterol, ain't they? All right, y'all, let me think. So yeah, those are all you're doing on those. So questions on that today? Now, online, I sent you a Z chart table in your email, okay, Megan? And that's what I was using to get my percentiles from them Z scores, okay?
Okay.
So we'll stop now because I don't want to push forward. I want everybody sort of catching up with me. So try to get up to 6C done. Next class, for the support, I'm going to show y'all how to reduce fractions. Do y'all know how to reduce fractions? So what I mean by reduce fractions, you reduce 8/10. Now calculators, I just punch in 8/10. It'll give you a decimal, and then you cut it you hit math and enter twice, it turns it back into a fraction. Are there any factors common between 8 and 10?
2.
2. So since 2 is a common factor, you're gonna divide both these by 2. So 8 divided by 2 gives me 4, 10 divided by 2 gives me a 10. Now, does 4 and 5 have any common factors? No, so he just reduced my fraction for me. You remember doing that stuff, don't you? Sometimes if you don't know the factors, like big factors, you can take out little factors and then the next little factor and keep doing that until you get them. Did it work on your calculator?
I didn't do it.
Oh, you don't have
Oh,
it?
yeah, you know what, I still have problems with my, like squares. Certain numbers won't square, gives me an error. Like, I was trying to do this homework, and some of them were still giving me E's.
I bet it was because you're using that subtraction key instead of that little negative key on that calculator. Let me see if I show you.
These were numbers in the various.
But some of them had negative numbers, remember when you.
I know what you're saying, I know what you're saying.
So I come on here and I hit this button here and A and try to square that. Oh, hold on, we got something already. So if you hit the subtraction, it's always going to try to subtract from the last answer on there. So let me see one that you respond that way. But it was giving you E.
Yeah, and it was on the same right, it was when I was doing the standard deviations and I was doing the math towards the end of it. It would be like 0.002 and I would square it and it'd be fine. And then I would go to point.
Oh, yeah, some
And
of
then all of
those,
a sudden.
what an E means is that it's got a lot of decimals in it.
Yeah, but the ones before and after would show up though, that's the thing.
Okay.
You see what I mean?
Uh-huh.
There was.
So you must have very, very little deviation on some of those.
I'll bring one next time, but it was still doing.
So it's almost like it's on the average or something, because it wasn't getting nothing to add them up or nothing.
I'll bring one next time.
Okay, that'll work. Then you can find it. We'll see what they got going on. So you got your project to do. I sent you that little project to do.
Yeah, I have that.
Mhm.
And when I research my test, you're trying to let you know not to research it.
Huh?
The test.
When did you figure out you
just
want?
want me to email it to you?
Email me whenever you're ready, and
Okay.
all I gotta do is just click one button in there. All right, so I will stop this recording.